Okay, I'm going to do this back of the worksheet homework from bottom to top. Now, I don't have a compass on this little PDF writer that I'm using. I'm just going to give you kind of an idea. So if you're working on this from home or from school later, you put your sharp edge of the compass here, and then using the same measured distance, you're going to do an arc and an arc at whatever measure you choose. Then you move your sharp edge to this new spot, arc, and you move your compass again to this new spot, arc, and that's going to create an intersection point that is the corner of my rhombus. So if I wanted to connect a rhombus right here, I could connect here to here, here to here, but this is actually asking for an angle bisector of a rhombus. So what they want me to do is connect the diagonal through this point of intersection, and that creates a bisected angle. Show me that it's bisected by marking those two angles congruent. And we're done. So you're going to do the construction of a rhombus, all those steps, but then connect the diagonal. That's what creates the angle bisector, because it's a property of a rhombus that the diagonal bisects the angles. For this last construction over here, we put our sharp edge here on B, for example, and whatever distance you're going to do, remember you want your distance to be at least bigger than the midpoint. You're going to go arc, arc, and then put your sharp edge over here on A and do arc, arc, and then wherever those 2 points connected, connecting right here, that's going to be your perpendicular bisector. I know that's not perfect. Okay, so besides those constructions, we are going to practice a couple triangle congruencies here. Remember that our choices for triangle congruency are the follows. We could be congruent if we have 3 sides. We could be congruent if we had an angle, a side, and an angle. If we had a side, an angle, and a side, or if we had an angle, and then a side. This one can also be reversed to SAA. So let's go see what we have. Over here I have a side, an angle, and a side. So yes, this one is going to work from my list. Let's go do it. I'm now going to list out all the corresponding parts. So side OR is the side that has 3 marks on it. So go over there and find side CI. Notice that I go from no mark to 1 mark, so I have to go from no mark to 1 mark on the other corresponding part. Angle R is congruent to angle I. I can just call it a 1-letter name because it's not a shared vertex, but I could also call this angle ORG and angle CIM if I wanted. Okay, last is this other side, RG, is congruent to IM. So I'm going to say triangle OGR is congruent to triangle CMI by SAS. How'd you do? This next one has a sneaky little reflexive side right there. Do you see that side HY is congruent to itself? And then we're also going to say that side HN is congruent to side HU, and side NY is congruent to side UY. Well, is 3 sides enough? Yay, yes it is. Side YHN is congruent to side YHU. Sorry, triangle YHU. All the corresponding parts. Last but not least, we have an angle, angle side, angle, angle side. This is also going to work. So here I go. Angle M is congruent to angle O. They both have 2 marks. Angle R is congruent to angle N. And side AR is congruent to side NS. So triangle RMA is congruent to triangle SON, sun. All right, how'd you do? Last but not least, you're going from one pre-image to a post-image, and you're telling me what happened. So pre-image right here, shape 1, is moving to post-image shape 4. What do you think? Well, if I look at the distance between that, like if I draw a connecting segment from here to here, could I picture it being reflected over an opposite segment, like going through here? Actually, it does kind of look like a reflection now that I look at it. So what is this slope? This slope is going down 2 over 3, down 2 over 3. So if my original slope is down 2 over 3, my perpendicular slope is up 3 over 2. So I'm going to say that this is a reflection over the line, y equals 3 halves x, and now I need an x1, y1. So if I go put a dot right here in the middle, up 1, 2, 3 over 2, I could say that the equation of this line, oops, it's not a very good drawing, hang on. Okay, using the 0.31, so x minus 3 plus 1. And there it is. It's a reflection over that line. Okay, pre-image. Pause the video, try the next one. This time, pre-image is shape 4. And shape 3 is where we're going. Well, this guy looks like a rotation. And a lot of students have asked me, like, how the heck do I find that rotation point? Like, I know it's a rotation. And if you don't get the exact center that it's rotating around, that's fine. But let's just go see if we can, like, guess it. I don't know. I'm just going to literally throw a dot somewhere. I need to count opposite slopes. So if I go from the center up to over 1, then it goes from there to there. Does that look like a right angle to you? Not quite. So let's go try another dot. How about right here? Does that look like a right angle to you? Huh, it kind of does. Let's go test another one. Let's go like this. Hang on, let me use some straight edge to actually make it. Looks too big. Let's do the one that seems closer right here. Let's do this line. Oh, we already did that one, sorry. Let's do this line. Okay. Not seeing right angles anywhere else. So we're going to keep trying, keep trying. So I want you guys to challenge yourselves. Like, go pick another dot. See if you get a right angle. Go pick another dot, keep testing it, and see if you can see the slope and the perpendicular slope. I'm going to share this tomorrow in class to see if anybody got it. Okay, we know it's a rotation. I want to see if anybody can guess and check that center of rotation, kind of like I was just showing you, okay? Last one, pre-shape image 4, going to shape 2. So this time we're jumping over to this guy. This guy is just translated. Did you count it? So taking this point is back 1, 2, 3, 4, 11, and down 1, 2, 3, 4. Count it again to be sure. So I'm getting that it's back 11 and down 4 from the original shape. So this one is a translation. To double check it, we're going to go count another point. Back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, down 1, 2, 3, 4. Looks good. All right, so hopefully you see what I mean with those. You didn't have to put the new shapes on there or identify any points. You had to say, hey, how did it get there? I want to see if anybody comes up with the center of rotation. That's going to be a fun challenge for you guys. All right, see you tomorrow.